Hey, in this video, we are just going to talk about what is organic chemistry and what is the beauty of the periodic table. And what is organic chemistry? It is just study of carbon. That's all. That is what is organic chemistry. In organic chemistry, you're going to just see what carbon can do and why carbon is so versatile and what kind of atoms and molecules can carbon form. Each functional group is its own chapter. So, what is so special about carbon? Carbon is one of the unique atoms on the periodic table which can form both partially positive charge or negative charge based on its neighbors. And it got these beautiful properties where it can exist in different forms. It can exist as diamond or graphite. Both have just pure carbon, just by its structural orientation, the properties change. Like diamond being very organized structure is a bad electric conductor, while graphite having a layered structure is a good electric conductor. So just based on the orientation, the carbon properties change. So now let's look at the periodic table. So you all are familiar with this periodic table in organic chemistry. Leave about organic chemistry, even in general chemistry, you all are familiar with this periodic table. If not, you wouldn't be here. One thing about organic chemistry is you don't need this whole periodic table. You just need this two sections. You need the S block and you need the P block. And even in the P block, this is just selective. So when you combine this S block and P block together, you're gonna get something, I call it them as organic chemistry periodic table. Just a small quick one. And the numbers you see, this is an old school periodic table or old style where they had it as 1A, 2A, 3A. So these is what I'll call them as the group numbers. So let us consider them. And if you consider them, you see that the carbon is in the center. So carbon has 4. That's why it can form 4 covalent bonds. And their group numbers, if you see this is group 1, 2, 3, 4. And with carbon being in 4, the number of valence electrons is their group number, if you go by this style. So what do you mean by number of valence electrons? So the electrons in the outermost shell are called valence electrons, and the valence electrons is equal to the group number. Now, how is this related to like outermost shell? So if you remember electronic configuration from your general chemistry, let's take for carbon, you have an atomic number of 6. You write it as 1s2, 2s2, 2p2. So if you look at 2s2, 2p2, it's the outermost shell is 2. So the number of valence electrons is going to be 4. So now the number of bonds they can form. So groups 1 to 4 form the number of bonds equal to their group number. So means, hydrogen, beryllium, boron, carbon. They are going to form the bonds, whatever is equal to the group number. And the groups 5 to 8 are going to form 8 minus their group number. Why are we using this formula? Because the number of bonds plus number of lone pair electrons is going to form a group number. And up to carbon 1, 2, 3, 4, we don't have any lone pair electrons. That's why we are using the number of bonds is equal to group number. While the lone pair electrons is group number minus number of bonds, right? So that is the reason we are having anything can form up to 8 bonds. So that's why 8 minus their group number is going to give you the number of bonds. And if you separate 8 minus number of bonds, you're going to get the lone pair electrons. So that's how you calculate number of bonds and lone pair of electrons just from the periodic table. I hope this helps. Thank you.